All right. Good day, and welcome to the physics class. Now, in today's class, we shall be talking about applications of Newton's second law. Applications of Newton's second law. And if you remember that we had talked about Newton's second law in our last class, right? So in today's class, we want to talk about how to apply what are the different ways in which Newton's second law can be applied. All right. If you remember that Newton's second law was talking about force, it was actually talking about the relationship between force and acceleration, right? That's why the expression for Newton's second law is F is equals to ma, mass multiplied by acceleration. So there is a relationship between force F and acceleration a, right? So that is why it is important to talk about different kinds of forces that we have, since Newton's second law is talking more about the relationship between force and acceleration. Okay, now, what are the objectives that we are going to cover in this lesson? Now, in this lesson, we'll be talking about the concept of normal force as the contact force which acts at the right angle on the surface. We are going to explain what normal force is. We are going to understand how to apply normal force in real life situations. Now, the second thing is to describe the tension force, the friction force, and the drag force. We shall be talking about these three types of forces in much details. All right, so without wasting time, let us go to normal force. Now, you can always wonder what happened when you place your book on the table and the book did not fall down, or when you lean on the wall, you are resting your back on the wall and you are stable, right? You want to wonder how come you are stable and you are not falling down? How come the book is staying on the table without falling down? Now, in physics, this is as a result of normal force. The normal force is the force that surfaces exerted to prevent solid objects from passing through each other. Now, from this definition, you can see that normal force exists between solids, between surfaces of solids, right? So it is that force that they exert on each other that prevent them from passing through each other. Now, if you look at this diagram here, I'm sure you can see this diagram very clearly. Beautiful. Now, you can see that you have an object on a surface. Let's say that the surface is a table, as you can see from that example, right? Now, there are two forces that are acting on this arrangement. There is an object on a table, two forces are acting, right, on that arrangement. Okay, so there is a normal force that is acting upward from the table to the object. There is a normal force that is acting upward from the table to the object. You also know that when you have an arrangement like this, there is a weight, that is acting downward, right? There is a weight as a result of gravity that is acting downward. So those are the two opposing forces that are acting on that object. Okay, let me explain this in a better detail, for much more better understanding. Okay, so Good. So we have this. Again, let's say we have a table. A table is standing like this. I'm sure you have seen this kind of table before. All right. So on this table, we have a cup of coffee. Go. This is a common thing we see at home. We have a cup of coffee. No, that's not a very beautiful drawing, but you are going to enjoy it like that. Okay, good. This is a cup of coffee and this is a table. Now, when you have this, there is a force acting downward. The table, the cup is exerting a force on the table, and that force is as a result of the weight of that cup. So there is a force downward, which is because of weight, right? You know that the weight is equals to mass multiplied by gravity, meaning the mass of the cup multiplied by the constant g, gravity, acceleration due to gravity. Now, there is another force, because if there is no other force, it means that that weight will be pushing down on the table. But because the weight, the cup is stable on the table, it shows that there is another force that is acting on the opposite, right? Which is like this. It is acting on the opposite. And this particular force is called a normal force. So it is because of this normal force that the cup is staying comfortably on the table. That is the concept of normal force. It is always acting between two solid surfaces that are in contact. Now, it is important you know that number one, the two surfaces has to be solid. Number two, they have to be in contact, meaning they have to be touching each other. Good. I'm sure you understand that. Let's go to the next type of force. I know you can think of so many different kind of examples for normal force in real life. I've given the example of a table, of a cup on the table, of your book on the table, of you resting on the wall. There are so many real life examples you can take for normal force. Now let's go to the tension force. Now, this is another type of force. It is defined as the force that is transmitted, right? Meaning that is transferred through a rope, string, or wire when pulled by force acting from opposite side, right? So this is tension force. Now, as you can see from that definition, tension force is acting on a rope or a string or a wire or anything like that. So when something is pulling the rope, right, you have something pulling the rope, then it shows that inside that rope there is going to be a tension force, right? An example that you can have now, let's see if we can get a picture. No, no, no. Good. Let's see if we can get a picture for tension force. Okay, tension force. So you can see this very interesting example. Two people are pulling the rope on the opposite side. So inside that rope, there is going to be a tension force. That is a very good application of a tension force. Okay, so let's go. So now, in simple term, tension force is that force that exists or that is transmitted through a rope, a string, or a wire when they are pulled in the opposite sides. So it means that for you to have a tension force, there has to be a rope or wire or string, then they have to be pulled, right? They have to be pulled on the opposite side, as you can see there. All right, so let us go to another type of force that is very interesting. This is called a friction force. And I'm sure this is not the first time you will be learning about a friction force. A friction force is the force that resists. It resists the motion when a surface of one object come in contact with the surface of another object. Now, you will see that in friction force also, we have two surfaces in contact. But the difference between friction force and normal force is that in friction force, there is movement. In normal force, there is no movement. So when you have two bodies in contact that are sliding or are moving against each other, then you have a tension, you have a friction force. You have a friction force. All right, so as you can see from here, this man is trying to pull this box, on the ground. Now there is a friction force that is acting, to the opposite side. Now, as you can guess, you will see that inside this rope, we are going to have a tension force. But here, right, there is a friction force that is acting towards the opposite. When this man is pulling to the left, no, to the right, then the friction force is acting towards the left around the surface in contact. We are going to talk more about friction force in our next lesson, inshallah. Okay, so let's go to the last force for today. The last force we shall be talking about in this class is drag force. We shall be talking about drag force. Now, as you can see on the slide, drag force is resistance force. Drag force is resistance force um, caused by motion of body through fluid, like water or air. This drag force acts opposite to the direction of oncoming flow velocity. Now, this drag force is like frictional force, but it is acting within a fluid, that is water or air, that is liquid or gas. So the opposite force to a flow, right, of the fluid is called the drag force. Is that okay now? So these are the types of forces we shall be talking about, today. We shall be talking about today. All right, so in this lesson, we have learned many things. We have learned about the normal force, we have learned about the friction force, we have learned about the drag force, and we have learned about the tension force. And like I told you, this lesson is all about different types of forces. You will see that there is normal force and friction force are similar. But like I told you, friction force acts when the bodies are in motion, when they are moving, right? And the drag force is also similar to friction force, but drag force exists when you have fluid that is liquid or solid. Sorry, that is liquid or gas, please. That is liquid or gas. So I hope you understand this lesson, right? If you have more questions, you can post them to me. Then I'm going to, answer your questions. So I wish you good luck and have a nice day.